Hello everyone. In this video, we are going to discuss about the topic normalization in database management system. Okay, now let's see the definition of normalization. Normalization is a technique for grouping data into multiple related tables in order to minimize data redundancy. So, so it is a technique for organizing data, okay, into multiple related tables so that we can minimize the data redundancy. So this is the main concept in normalization technique, okay, to minimize data redundancy. So the main aims to create a collection of relation schema that allows us to store data without unnecessary duplication. So while also making it simple to retrieve data. Okay, so now let's see some of the issues happens due to data redundancy. The first one is that data becomes larger as it is repeated. So when data get repeated, so automatically the data becomes larger. Size of the data becomes larger. So that is the one kind of issue, and the second issue is that insertion problem. That is insertion anomaly. Third one is that deletion problem, also called as a deletion anomaly. Then final one is that updating problem, also called as an updating anomaly. Okay, for an example, consider a student table. So in this student table, we have a column register number, name, department, HOD, and office number. So here we have different register number like 1, 2, 3, 4, the name Raj, Joe, Mickey, Tim, and the department, HOD, and office number. Department is CSC, HOD Mr. Luke, and office number 1, 2, 3, 4, 5. So all these value remain same. Okay, these values are not changed. Okay, so here this kind of problem is called as redundancy. Okay, data redundancy, repetition of data. Okay, so now let's see what is an insertion problem. Inserting a redundant data in every new row in a table is called insertion problem. That is the insertion problem. For example, so in the same student table, we are going to insert a new record. So this is our new record. Okay, so new record have register number 5, name Sheldon, and the department same CSC, HOD, and office number. So actually we are going to insert this new record into the old table, the student table. Okay, but only these two values are the new one, but the remaining department, HOD, and office number all are the same. So repeated data. So repeated data. So this is the kind of anomaly which is present in this problem, insertion problem. Okay, so while we are adding the new record, the repetition, that is the data is getting repeated. Okay, so this is the problem. The next issue is that deletion problem. Deletion problem is that when some data get deleted in the table, so related data will also get deleted. See in this example, um, so the whole record, that is the whole tuple, got deleted. Okay, so for example, if you want to delete this the whole like this tuple, so all the records like along with the register number, name, the whole department, HOD, and office number, every all the details will get deleted. Okay, so this is the issue in the deletion problem. Department details got deleted along with the student information. Next one is that updating problem. So in the updating problem, for example, take the HOD, Mr. Luke leaves and new HOD called Mr. Joel. He joins. Okay, so when new HOD joins, all the old records has to be updated. So again, this will be an anomaly in updating problem. Okay, so all the records has to be updated with the new HOD. So this is also a kind of a issue. Now solution, how to solve this? Okay, so actually normalization is a technique to organize the data into multiple related tables. So what we can do is that in the student table, we can split the student table into two, student table and the department table. We can split the student table and department table. See, if we split the student table and department table, we cannot eliminate the data redundancy. Okay, so actually normalization technique is to minimize the data redundancy. It is a technique to minimize the repetition of data. See, even if we have split the table, student table, into student table and department table, again some data, some redundant data we have. Okay, this cannot be avoided, but we can minimize it. Okay, by using normalization technique. Now let's see the solution for insertion problem. So actually we have splitted the data, table, student table and department table. So now we have the separate table for department. In that we have CSE, department CSE, HOD, Mr. Joel, then office number is this is 12345. Okay. Now let's check now. For example, if I'm adding the new record like 3, register number 3, then a name again I'm adding Jack, then department CSC. That's all. So now I have inserted a new record. Okay, so again there is no need for me to include this HOD and office number again, because these two tables are related with the department. Okay, so again if you want to add one more record like 4, then again name like Ram, then department CSC. Okay, so so again there is no need for me to add these details, HOD and office number. Simply I can insert the records. Okay, so this is the solution for insertion problem. Now let's see the solution for deletion problem. So deletion problem, again already we have split it, right? Student table and department table we have. So in the department table we have the values for the department CSE, HOD Mr. Joel, then office number 12345. All these records are there. Okay, so actually for example if you want to delete the student detail alone like register number and name, this will not affect, this will not reflect the department table. Okay, this will not reflect or this will not delete the HOD or office number values. Okay, only the student table alone will get deleted. Okay, so this is the solution for deletion problem. Next, solution for updating problem. Likewise, so the new, actually this is the student table and this is the department table. So here the department table, new HOD joins Mr. Joel. Okay, the previous HOD, he he left. Okay, so the new HOD joins. Only we can update the details in the department table itself. There is no need to update anything in the student table. Okay, so automatically the records will get updated because it is linked, right? So this is department is linked with the student table. Only one column is enough to update. So this is a solution for updating problem. Next, let us see the types of normalization. So we have 1NF, 2NF, 3NF, then BCNF, first normal form, second normal form, third normal form, and Boyce Codd normal form. In this video, we'll discuss about the first normal form. Okay. So what is first normal form or 1NF? If and only if the domain of each attribute contains only atomic values or indivisible values, and the value of each attribute contains only a single value from that domain, then a relation is said to be in first normal form. So what is first normal form is that if a relation contains any multiple values, okay, then that particular relation is nothing but it is the table. Okay, so if any table has like multiple values, then that particular table is not in first normal form. Okay, it should contain only atomic values. So this first normal form have four rules. Okay, now let's see the first rule number 1 is that each column should have atomic values. Each column should have atomic values. Values like A, B and C, D are not allowed because this is multiple value. Okay, these are not allowed. And every table in the database should be in first normal form. Otherwise, the database design is considered as poor. Now let's see this example. In this table, we have column 1 and column 2. Okay, so in column 1 we have value, single value. This is an atomic value A. Then the second record we have the value B. Whereas in column 2, in the first record, we have A, comma B. So this is wrong. Okay. This is so if a table has a value like this, multiple value, then that particular table is said to be uh, it is not at all present in first normal form. Okay. Likewise, C, comma D. This is also wrong. So that is rule number 1. Each column should have an atomic value. Okay, let's see the rule number 2. So rule number 2 is that column should contain only same type of values. Different type of values are not allowed. Okay. So in the example, we have column ID number and name. Okay. So ID number we have we supposed to have a numerical values, right? So here number 1, that's correct. But the second one is that we have a name, there is a character string Raj. So this is wrong. We are not supposed to have these different types of values in a particular column. Likewise, name Anand, yeah, it's correct, this value is correct. Whereas the second value, we have a numerical value, this is wrong. So different types of values are not allowed. That is rule number 2. Next is rule number 3. Rule number 3 is that each column should have unique name. Okay, unique name. There should not be any repetition of name in the column. Okay. Like register number, name and departments, all are unique only. Next, rule number 4. Values stored in the table can be of any order. Okay. So values, for example, if you take ID number, it starts with a 10. The second record is 4. Okay. So it can be of any order. That is rule number 4. Now let's see an example. So consider a student table. Okay. This is a student table. We have the column register number, name and subject. Okay, so we need to check this relation or table is in first normal form, whether it is satisfying the all the rules in the first normal form. Okay, then only that particular table or database design is considered as good. Otherwise, it is considered as poor. Okay, so we need to check all the rules. Rule number 1 is that each column should contain only an atomic value. Okay, so register number. Yeah, in this column we have an atomic value. Okay, everything is fine. Rule number 1 satisfied. Then here, yeah, atomic values it is satisfied. But in the subject we have multiple values. So this is so we cannot now we can say that this table is not in first normal form because it does not satisfy the rule number 1. Okay, in two records it is having the multiple values. Okay, so now what should we do? What is the solution for this is that we can split these two values and put it in a new record. Okay, so let's see the solution. So in this solution we have register number, name, subject, the same. So register number 1001, name Jack, then subject DBMS. Again the same register number 1001, name Jack and CN. There is computer networks. Likewise for the next record for 1002, name Joe, then subject Python. Register number 1002, name Joe, subject OS. Okay. Then the remaining record 1005, that is name Nick, NLP. Subject is NLP. Now we can check this table is present, that is it is in a first normal form. Yeah, this satisfied rule number 1 because every column have an atomic value. Likewise, rule number 2 is that each column should have a same type, right? So yeah, that also satisfied. So register number all are numeric, name, character string, subject also, so it satisfies rule number 2. Next, rule number 3, yeah, each column should have a unique name. It satisfies rule number 3 also. Then rule number 4 can be of any order. So now this table it is in first normal form. Okay, this table is in first normal form, hence it is satisfied all the rules. Okay, so this is about the first normal form. Yeah. So in this video, we have discussed about the introduction, that is what is normalization and what are the issues due to data redundancy, and how to solve those problems, those issues we have seen, and also we have discussed about the first normal form and how to solve the solution for the first normal form also. So in the next video, we can discuss about the remaining normal forms, and hope you have understand all the topics. all the definitions and descriptions. Thank you.